It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Welcome to Unacademy Ascend YouTube channel. In this 2 months crash course on engineering mathematics for GATE and ESE 2021, today I will be discussing previous year GATE questions of differential equations. For the differential equation dy by dx plus 5y equal to 0 with y of 0 equal to 1, the general solution is first option e power 5t, e power minus 5t, 5 into e power minus 5t, e power square root of minus 5t. We have to solve the homogeneous differential equation dy by dx plus 5y equal to 0 with y of 0 equal to 1. dy by dx plus 5y equal to 0. dy by dx is minus 5y. dy by y is equal to minus 5 dx. Integral 1 by y dy is integral minus 5 dx. Continuation. Log y equal to minus 5x plus c. This is equation 1. This is equation 2. In the problem, it is given that y of 0 equal to 1. Therefore, log 1 equal to 0 plus c. Therefore, c equal to 0. The value of c is 0. Log y is equal to minus 5x. Therefore, y is e power minus 5x. The value of y is e power minus 5x. The problem is given as dy by dx, so solution must be in the form of dy by dx in terms of e power 5x, but in the options they have given dy by dt, so e power minus 5t. Next column, solve for y if d square y by dt square plus 2 into dy by dt plus y equal to 0 with y of 0 equal to 1, y dash of 0 equal to minus 2. Y of 0 is 1 and y dash of 0 is minus 2. First option, 1 minus t into e power minus t, 1 plus t into e power t, 1 plus t into e power minus t, 1 minus t into e power t. d square y by dt square plus 2 into dy by dt plus y equal to 0. If you write in operator form, d square plus 2d plus 1 of y is equal to 0. The auxiliary equation is m square minus 2m plus 1 equal to 0, m plus 1 whole square equal to 0, m is equal to minus 1 comma minus 1. Now the solution is y is equal to c1 plus c2t, c1 plus c2t of e power minus t. Continuation, y is equal to c1 e power minus t plus c2t into e power minus t, called it equation 2. Now differentiate y with respect to t. Y dash equal to minus c1 e power minus t plus c2 into e power minus t, differentiation of t is 1 plus t into minus e power minus t, called it equation 3. Now in the data they have provided two boundary conditions. One is y of 0 equal to 1, another one is y dash of 0 equal to minus 2. Y of 0 equal to 1, y dash of 0 equal to minus 2, and now 1 is equal to c1 plus c2 into 0 is 0, therefore c1 equal to 1. Next, y dash of 0 equal to minus 2, so minus 2 equal to minus c1 plus c2. Since c1 is 1, minus 2 equal to minus 1 plus c2, therefore c2 equal to minus 1. c1 is 1, c2 is minus 1, therefore the solution is y is equal to c1 is 1, so e power minus t minus t into e power minus t, therefore y is equal to 1 minus t into e power minus t, 1 minus t into e power minus t. So correct answer is 1 minus t into e power minus t, first option. Next problem. The solution of f double dash x plus 4 into f dash x plus 4 into f of x equal to 0. f1 of x is e power minus 2x. f1 of x is e power 2x. f2 of x is e power minus 2x. Third option. f1 of x is e power minus 2x. f2 of x is x into e power minus 2x. Last option. f1 of x is e power minus 2x. f2 of x is e power minus x. In this problem, we have to find out two independent solutions of the given differential equation. The differential equation is f double dash x plus 4 into f dash x plus 4 into f of x equal to 0. That is y double dash plus 4y dash plus 4y equal to 0. The given equation can be written as in operator form d square plus 4d plus 4 of y equal to 0. The auxiliary equation is m square plus 4m plus 4 equal to 0. m plus 2 whole square equal to 0. m is equal to minus 2 comma minus 2. The solution is y is equal to c1 plus c2x of e power minus 2x. Therefore, y is equal to c1 e power minus 2x plus c2x into e power minus 2x the independent solutions are e power minus 2x and x into e power minus 2x. One solution is e power minus 2x, another solution is x into e power minus 2x. The two independent solutions are e power minus 2x and x into e power minus 2x. Understood? The particular solution of next problem. The particular solution of d square y by dx square plus 3 into dy by dx plus 2y equal to 5 cos x is first option 0.5 cos x plus 1.5 sin x. Second option 1.5 cos x 0.5 sin x. Third option 1.5 sin x. Fourth option 0.5 cos x. The particular solution of d square plus 3d plus 2 d square plus 3d plus 2 of y is equal to 5 cos x Now the particular integral is 1 by d square plus 3d plus 2 5 cos x. Replace d square equal to minus 1. If you replace d square equal to minus 1, 1 by minus 1 plus 3d plus 2 5 cos x. That can be written as 1 by 2 minus 1 plus 3d 5 cos x. Multiply numerator and denominator with 1 minus 3d. One minus 3d by 1 minus 9d square of 5 cos x. Now replace d square equal to minus 1. If you replace d square equal to minus 1, you will get 1 minus 3d by 1 minus 9 of minus 1 cos x. That is cos x minus 3 into differentiation of cos x by 10. Right? In the problem they have provided 5 cos x. That's why I am writing 5 outside here. Now 5 by 10 means 1 by 2 of cos x minus 3 into differentiation of cos x is minus sin x. That's why minus of minus sin x is plus sin x. That implies cos x by 2 plus 3 by 2 sin x. That is 0.5 cos x plus 1.5 sin x. 0.5 cos x plus 1.5 sin x. 0.5 cos x plus 1.5 sin x. First option is correct. Next problem. The solution for the following differential equation with boundary conditions y of 0 equal to 2, y dash of 1 equal to minus 3 is where d square y by dx square is 3x minus 2. First option, y is equal to x cube by 3 minus x square by 2 minus 3x minus 2. Second option, y is equal to 3x cube minus x square by 2 minus 5x plus 2. Third option, y is equal to x cube by 2 minus x square minus 5x by 2 plus 2. Last option, y is equal to x cube minus x square by 2 plus 5x plus 3 by 2. Now the given differential equation is d square y equal to 3x minus 2. So d square y equal to 3x minus 2. Therefore the auxiliary equation is m square equal to 0. So m equal to 0 comma 0. Therefore complementary function is c1 plus c2x of e power 0x. Now the particular integral is 1 by d square of 3x minus 2. 1 by d square is nothing but 1 by d into 1 by d of 3x minus 2. 1 by d means integration. Integral 3x minus 2, 3 into x square by 2 minus 2x. Continuation. Again integration. 3 into x cube by 3. So x cube by 2 minus 2 into x square by 2, x square. So x cube by 2 minus x square. General solution is complementary function plus particular integral. Y is equal to c1 plus c2x of e power 0x plus x cube by 2 minus x square. Therefore y is equal to c1 plus c2x plus x cube by 2 minus x square. Called it equation 1. Next, now the boundary conditions. Y of 0 equal to 2. Y of 0 equal to 2. Two is equal to c1 plus 0 plus 0 plus 0. Therefore c1 equal to 2. Another boundary condition. Y dash of 1 equal to minus 3. So we have to calculate y dash. Now y dash equal to 0 plus c2 plus 3x square by 2 minus 2x. The boundary condition is y dash of 0 equal to y dash of 1 equal to minus 3. Y dash of 1 equal to minus 3. Minus 3 equal to c2 plus 3 by 2 minus 2. 3 by 2 minus 2 is minus 1 by 2. That implies c2 equal to minus 3 plus 1 by 2. c2 equal to minus 5 by 2. c1 is 2, c2 is minus 5 by 2. Therefore the solution is y is equal to c1 2 minus 5 by 2x plus x cube by 2 minus x square. Y is equal to 2 minus 5x by 2 plus x cube by 2 minus x square. Third option. Next problem. The solution of the first order differential equation x dash of t equal to minus 3 into x of t. X of 0 is x naught is first option. X of t is x naught into e power minus 3t. Second option, x of t is x naught into e power minus 3. Third option, x of t equal to x naught into e power minus t by 3. Fourth option, x of t is x naught e power minus t. The solution of first order differential equation x dash of t equal to minus 3 into x of t. Now dx by dt equal to minus 3x. Dx by x equal to minus 3 dt. Integral 1 by x dx is integral minus 3 dt. Continuation. Log x equal to minus 3t plus c, or you can write log c. Now given that the boundary condition is x of 0 equal to x naught, x of 0 equal to x naught, so log x naught equal to 0 plus c. Therefore log x equal to minus 3t plus log x naught, because since the value of c is log x naught. Now continuation. Log x minus log x naught equal to minus 3t. Log x by x naught equal to minus 3t. X by x naught equal to e power minus 3t. Therefore x is equal to x naught e power minus 3t. So finally the value of x of t is x naught into e power minus 3t. X naught into e power minus 3t. Therefore correct answer is first option. Next problem. For the equation x double dash t plus 3 into x dash t plus 2 into x of t equal to 5. The solution x of t approaches the following values as t tends to infinite. Option A 0, option B 5 by 2, option C 5, option D 10. For the equation, the solution x of t approaches the following values as t tends to infinite. First we have to find solution. After that, when t tends to infinite, x tends to which one of the following we have to find out. Now The differential equation is x double dash t plus 3x dash t plus 2 into x of t equal to 5. Now x double dash t d square plus 3d plus 2 of x of t equal to 5. The auxiliary equation is m square plus 3m plus 2 equal to 0. m plus 1 into m plus 2 equal to 0. m is equal to minus 1 comma minus 2. Therefore, the complementary function is c1 e power minus t plus c2 e power minus 2t. Now, the particular integral is 1 by d square plus 3d plus 2 into 5. Whenever constant term is given, you have to write constant into e power 0t. Replace d equal to 0. Then you will get 1 by 0 plus 0 plus 2, 5 into e power 0t. Finally, 5 by 2. Now the solution is x of t equal to c1 plus c2 in c1 e power minus t, c2 e power minus 2t plus 5 by 2. As t tends to infinite, x of t equal to e power minus t is 0, e power minus 2t tends to 0 plus 5 by 2. Therefore, the conclusion is as t tends to infinite, that means limit t tends to infinite x of t equal to limit t tends to infinite c1 e power minus t plus c2 e power minus 2t plus 5 by 2, that is 5 by 2. Final answer is 5 by 2. 5 by 2 is the correct answer. Next problem. The solution of d square y by dx square plus 2 into dy by dx plus 17y equal to 0. Y of 0 is 1, y dash of pi by 4, y dash of pi by 4 is 0. And now, if you write the given equation in operator form, d square plus 2d plus 17 of y equal to 0, the auxiliary equation is m square plus 2m plus 17 equal to 0. Now, m is minus 2 plus or minus square root of b square minus 4ac by 2a, that is minus 2 plus or minus 8i by 2, that is minus 1 plus or minus 4i, minus 1 plus or minus 4i. Roots are imaginary, therefore the solution is y is equal to e power minus x of C1 cos 4x plus C2 sin 4x. Called it equation 1. In this problem, they have provided two boundary conditions. Y of 0 equal to 1. Y dash of pi by 4 equal to 0. That's why you require y dash. That's why I am differentiating. Y dash equal to e power minus x of minus 4c1 sin 4x plus 4c2 cos 4x plus c1 cos 4x plus c2 sin 4x into minus e power minus x. Called it equation 2. Now y of 0 is 1. One is equal to e power 0, c1 cos 0. Therefore c1 equal to 1. Next, y dash of pi by 4 equal to 0. That implies 0 is equal to e power minus pi by 4 e power minus pi by 4 of minus sin pi by 4 into 4 sin pi 0 plus 4c2 cos pi. So 4c2 into minus 1 plus minus 1 plus 0 minus e power minus pi by 4. Continuation. 0 is equal to minus 4c2 into e power minus pi by 4 plus 1 into e power minus pi by 4. Zero is equal to minus 4c2 plus 1 into e power minus pi by 4. That is, you can write like this. This can be written like this. Minus 4c2 e power minus pi by 4 equal to minus e power minus pi by 4. 4c2 equal to 1, c2 equal to 1 by 4. Therefore, y is equal to c1. c1 is 1. So substitute c1 is 1 here. E power minus x of cos 4x e power minus x of cos 4x. c2 is 1 by 4. So 1 by 4 sin 4x. So y is equal to e power minus x of cos 4x plus sin 4x by 4. Next problem. So final answer is e power minus x of cos 4x plus sin 4x by 4. Next problem. A solution of the differential equation d square y by dx square minus 5 into dy by dx plus 6y equal to 0 is given by first option. y is equal to e power 2x plus e power minus 3x, y is equal to e power 2x plus e power 3x, y is equal to e power minus 2x plus e power 3x, y is equal to e power minus 2x plus e power minus 3x. d square y by dx square minus 5 into dy by dx plus 6y equal to 0. This can be written as d square minus 5d plus 6 of y equal to 0. The auxiliary equation is m square minus 5m plus 6 equal to 0. m minus 2 into m minus 3 equal to 0. m is equal to 2 comma 3. Therefore, complementary function is c1 e power 2x plus c2 e power 3x. It is a homogeneous differential equation, that's why the solution is y is equal to c1 e power 2x plus c2 e power 3x. He has not provided any boundary conditions here, that's why among the given options we can understand that the solution is second option. Next problem. For d square y by dx square plus 4 into dy by dx plus 3y equal to 3 into e power 2x, the particular integral is. First option e power 2x by 15, second option e power 2x by 5, 3 e power 2x, c1 e power minus x plus c2 e power minus 2x. So here the particular integral of the given differential equation is, the particular integral is 1 by d square plus 4d plus 3, that is the operator 3 e power 2x. In the case of exponential function, replace d by alpha, here alpha is 2, d by 2. By replacing d by 2, we get 1 by 2 square 4, 4 to the 8 plus 3 into 3 into e power 2x, that is nothing but 3 into e power 2x by 15. So e power 2x by 5, the particular integral is e power 2x by 5. Correct answer is e power 2x by 5. Next problem. The solution of the differential equation dy by dx equal to x square y with the condition that y is equal to 1 at x equal to 0 is. First option y is equal to e power 1 by 2x, Second option, log y is equal to x cube by 3 plus 4. Third option, log y equal to x square by 2. Fourth option, y is equal to e power x cube by 3. Now, the given differential equation is dy by dx equal to x square y. By applying the method of variable separable, dy by y equal to x square dx. Integral 1 by y dy equal to integral x square dx. Log y equal to x cube by 3 plus c. The given boundary condition is y is equal to 1 when x equal to 0. Y is equal to 1 when x equal to 0. So log 1 equal to 0 plus c. So finally c is equal to 0. If the value of c is 0, then the solution is log y equal to x cube by 3. If log y equal to x cube by 3, by the definition of logarithm, y is equal to e power x cube by 3. So the solution is y is equal to e power x cube by 3. Last option. Understood?
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Thank you.